Hello children, our next definition is universal set. Whenever we talk about any set, its subset or elements of a set, it is usually in a particular context. For example, if we say if we say number system, or if we say natural number, integers, means we are talking about number system. So for this natural number, integers, set of natural numbers, set of integers, set of rational number, the biggest set is set of real number, we can say. Okay, one more example we can say, suppose if we study human population, okay, then the universal set will be the people in the world. Okay, so when we discuss, one more example we can take. Suppose if you want to study, or if you want to analyze the data of class 11 students, so for class 11, the students of all the school, okay, will be the universal set. So the biggest set is called the universal set. Okay, and we denote this universal set by capital U. So capital U is the symbol to denote, we use to denote this universal set. Suppose if we are talking about the set of right triangles, and then for the set of right triangles we can take the universal set of triangles or set of polygons. Okay, so for set of right triangle, set of triangles or set of polygons, we can consider the universal set of triangles, or we can also take set of polygons. So in each case, this set will be the subset of this universal set. Okay, so the in general, in simple word, we can say universal set is the biggest set. Okay, suppose if we are discussing the set of isosceles triangle, so among the set of isosceles triangles, the universal set is the set of triangles, or set of polygons, or we can say the set of two-dimensional figures. Okay, so in simple word, we can say universal set is the biggest set. We'll use the definition, we'll use this universal set later when we will solve word problem. Okay, when we solve word problem, and based on Venn diagram, so that we will discuss later. So now we will discuss operations on sets. Okay, operations on set. In number system, means this all natural number, integers, rational numbers. So in number system, we perform many mathematical operations like addition, subtraction, multiplication, division. Okay, so here in set theory, we perform a few operations, so we will discuss now. So the first is union of a set. Okay, union of a set. So what is this union of a set? So let A and B be any two sets, then the union of set A and B is denoted by this symbol. Okay, this is the symbol for union of two sets. Okay, so union of two sets A and B is denoted by this symbol, and we read it as A union B. Okay, how to read A union B? And union means the union of A and B is the set which consists of all the elements of set A and all the elements of set B. For example, if set A is given 1 and 2 and set B is given 3 and 4. Then union of these two sets is also a set. Okay, so union will be collection of all the elements of set A and B, means 1, 2, 3 and 4. Okay, union. This is same as addition in the number system, but that addition is different and this union is different. Now suppose if we have set A whose elements are 1, 2, 3, and in set B we have elements 3, 4 and 5. So A union B will be 1, 2, 3, 4, 5. As you know that we cannot repeat the elements in a set because union is also a set, so no repetition. Okay, so this is the union of set A and B. So in union we contain union is union which contain all the elements of set A and all the elements of set B. Now let's take this example. Here A is a set whose elements are A, E, I, O, U, and B is another set whose elements are A, I, U. So when you find A union B, you'll get A, E, I, O, U, which is nothing but set A only. Okay, here in this case A is a set whose elements are A, E, I, O, U, and B is a set whose elements are A, I, U. When you find union of set A and B, you'll get A, E, I, O, U, which is nothing but set A only. So from here we can write a result. When you observe, you will find that here B is nothing but subset of A. Okay, all the elements of B are also elements of set A. So from here we can write a very important result, that if B is the subset of A, then union is equals to A only. Okay, B is the means all the elements of set B are also elements of set A. So if B is the subset of A, then we can write A union B equals to A. Very important result. Or if A is the subset of B, here B is superset. Okay, B is super. B is the subset of A. So here A is superset, bigger set. Okay. So here A is the subset of B. So union will be equals to the bigger set only. Okay. So A is the subset of B. It means in this case A union B will be set B only. Very, very important result. Now some properties of the operation of union. In class 8 also we have discussed so many properties like commutative property, associative property. So for set theory also we will study some property. So the first one is A union B is equals to B union A. This is called commutative law. Means if we take union of A and B or B and A, then it will be same only. Okay, so this is called commutative law. And this one is associative, A union B union C. So if you take union first, union of A and B first and then union with C, or if you take union of B and C first and then you take union with A, then you will get same answer. This is called associative law. Now A union phi is A only. What is phi? Empty set. So if we can understand this third property by taking this example. If A is a set whose elements are 1 and 2, and we have to take the union of this set A with this phi. Phi means empty set. And what is union? Union means all the elements of set A and the next set. Okay, so here set all the elements of set A, and we know that phi is always there. Okay, so no need to write phi here. Phi is everywhere. Okay, phi is the subset of all the sets, so no need to write it here, but it is understood that phi is here. So union of A and means any set and phi is always that set. So this is called law of identity element, because this phi is identity, okay, identity of union. Phi is identity of union. As in multiplication, one is called the identity element, because any number multiplied by 1 is that number only, okay. And in additive identity is 0. Any number, if we add 0 with any number, we will get that number only. So this 1 is called multiplicative identity, 0 is called additive identity, and here in set theory for union, phi is the identity element, okay. Now A union A is A only, okay. Union with the set itself is that set only. So this is called idempotent law. Idempotent law, okay. And union with any set, if we take union with universal set, we know that universal set is the biggest one, okay. So in union we take the result is always the bigger set, okay. So union of set A with any union of universal set with any set is universal set only, okay. So these are the properties of union which we will use later when we will solve question based on the operations union and intersection, difference of two sets, okay. So now the second operation is intersection of set. Intersection of sets. In union, what we used to do, we used to write all the elements. Union of two sets A and B is nothing but all the elements, okay. So in intersection is just opposite. Intersection is only common elements. So if we have two sets, set A and set B, then intersection of this set A and B is represented by this symbol, intersection. This symbol is to represent this intersection, and we read A intersection B, okay. How to read A intersection B? And this A intersection B means set of all elements which are common to both A and B, okay. Intersection means common element. For example, if A is a set whose elements are 1, 2 and B is a set whose elements are 2, 3 and 4. So A intersection B, which is also set, so A intersection B means only common element. So here we have only common element, we have this 2 only. So this is A intersection B, okay. What if A is 1, 2 and B is 3, 4? So in this case no common element, okay, no element. It means here this A intersection B is empty set, phi, okay. In this case A intersection B is phi. So here also we have one very important result. If A is the subset of B, okay, it means B is superset, B is bigger, okay. So if A is the subset of B, in that case A intersection B. Now intersection means common. Now all the elements of set A are also the elements of set B. So intersection of A and B will be A only, okay. This result is very important because all the elements of set A is the subset of B. A is in B, okay. Set A is in set B. That is why the intersection of A and B is A. After this intersection we will discuss Venn diagram. So from Venn diagram also we will explain the meaning of this union and intersection. So it will be more, means you will understand better by using Venn diagram, okay. Now suppose if B is the subset of A, then in this case A intersection B is B only, okay. Now, like in union, we have some properties. Similarly, we will see some properties of this intersection. These two properties are clear. A intersection B equals to B intersection A. This is called commutative law, and this one is associative. Now the third property is phi intersection A or A intersection phi, means the common between phi and A is of course phi only. Okay, the common between means phi means empty. So any set and empty set, of course the common is empty set. Okay, so this is called law of phi, and intersection with universal set is always set A, or whatever the set B. Suppose if we are taking intersection of set B and universal set means the biggest one. Okay, and intersection means the common portion. So here union of set A and universal set is set A only. So this is law of universal set. The next property we have is intersection of a set A and set A, means with itself is a set A only. Okay, this is called idempotent law. And here this follows distributive law, means A intersection B union C, which is equals to A intersection B union C, which is equals to A intersection B, very important, A intersection B union A intersection C. Okay, this is called distributive law. It means intersection is distributive over union. Okay, now we will discuss this Venn diagram, which is very important, and also we will define this union and intersection by using Venn diagram. Till now we know that union means set of all the elements of set A and B, and intersection means only common portion. Okay, now how to define by using Venn diagram. So first we will see what is this Venn diagram. Venn diagram, which is very important topic of this chapter. So most of the relationships between set can be represented by diagrams, which are known as Venn diagram. This Venn diagrams are named after the English logician John Venn. Okay, that is why the diagrams are called Venn diagram, and we use this Venn diagram to represent set, okay, or relation between two or three or more sets. Okay, now we use a rectangle and closed curve like a circle. Most of the time we use circle only. So in Venn diagram, first we'll take a universal set, and this universal set is represented by a rectangle. Okay, this universal set is represented by a rectangle. So this rectangle represents a universal set, and any set which is a subset of universal set, so we represent set by circle. So from rectangle we represent universal set, and this circle we use to represent set. Okay, we can also take more than one set. We can also take set B. So suppose here I am taking universal set, a set of integers. So set of integers means we have some negative in numbers, some positive numbers, 0 we have, okay, -2, 4. It means this universal set, in this case I have taken universal set integer. Okay, here I have taken set of integer as a universal set, and this set A I have taken which is a set of this numbers 1, 2, 5. Okay, so this is the way we can represent this set A. Okay, now let's take an example. This I have taken at random only, so I am taking an example. Here we have a universal set whose elements are 1, 2, 3 up to 10. So here universal set contains 10 elements from 1 to 10. And here we have subset of U A. Okay, so here we have this A, set A, which is a subset of this universal set, and this A is defined as, means, or the elements of set A are 2, 4, 6, 8 and 10. Now how to represent it using Venn diagram? So in the Venn diagram we know that first we'll represent this universal set by a rectangle. So we'll draw a rectangle. This is our universal set. Okay, and this A is the subset, means this A will be inside this universal set only. So A is here. This is set A, and elements of set A are 2, 4, 6, 8, 10, and the remaining elements are here 1, 3, 5, 7, 9. Okay, so if you observe, you will find that in universal set we have all the 10 elements, but in set A we have these elements only. So this is the way we can represent this universal set and set A. Okay, now take one more example. Here universal set is given 1, 2, 3 up to 10, and we are given two sets, and both are subsets of universal set. So here we are given set A, which is 2, 4, 6, 8, 10, and set B also given 4, 6. Okay, so here this set B is the subset because all the elements of set B are also the elements of set A. So here we are given that B is also a subset of A, and A itself is a subset of universal set. Okay, now how to represent this using Venn diagram? So first we'll draw a rectangle which represents a universal set. Then we have set A. This is set A, and within this set we have set B. So within this set, so this is set B, and elements of set B 4 and 6. Okay, these are the elements 4 and 6, and in set A we have 2. 4 we have already written, so we have 2 here. 4 we have written, 6 we have written, 8 we have 10, and other than this we have here in the universal set. So remaining are here. 1 is here, 3 is here, 5 is here, 7 is here, 9 is here. Okay, so this is the way we can represent any set using Venn diagram. Now in brief we have seen the definition of union and intersection. Now how to represent this union of two sets using Venn diagram and intersection of two sets using Venn diagram. So we will see it now. So union of sets A and B. Okay, now we are talking about union of sets A and B. So we will take U as a universal set. Okay, U is the biggest set. So here universal set means represented by a rectangle, and we have two sets, set A and set B. Okay, now how to represent union of sets A and B using this Venn diagram? So this is universal set, and this is our set A, and this is our set B. Okay, So union of two sets A and B is the set which consists of all the elements of set A and all the elements of set B, okay, including those which are in both. Okay, so this is the way by which we can represent the union using this Venn diagram. So this is set A and set B. This shaded portion shows the union of set A and B. So this is A union B. Now mathematically or in symbol, how to write A union B? So A union B is the set of all the X such that this X belongs to A either in A or X belongs to B. Understood? Means union is the collection of all the elements of set A and set B, and also those elements which are common in both. Okay, so either in A or in B or in both. So this word or means union. Okay, be careful when we write union, we use word or, and when we find intersection we use and. Okay, so now let us see how to represent this intersection. This is union. Now intersection. So intersection of sets A and B. So for intersection we will take a universal set U, and we have two sets, set A and B. And what is this intersection? Intersection means common portion. So here in A and B, this is common. So this shaded portion represents A intersection B. Okay, this shaded portion represents A intersection B. And how to write symbolically? So we will write A intersection B is the set of all X such that X belongs to A and X belongs to B. It means this X is an element of set A and also an element of set B. Okay, that is why we are writing AND. So here AND means intersection. So whenever you find AND, it means we are talking about intersection. See, in union, either in A or in B, any element, whether the element is in A or in B or in both. So X belongs to A or X belongs to B. So this set will be the union of set A and B, and X belongs to A means A should be means this X should be common. Okay, this is the element of set A as well as element of B. So this is intersection. Okay, union and intersection. Now see, in both the cases there is something, means set A and B have some common element. Okay, but what if we have this case, universal set, and we have set A and set B? So it shows that there is no common element between set A and set B. Okay, this shows that there is no common element between set A and set B. It means no common element means common means intersection. No common means here A intersection B is phi. So if no common element, it means intersection is phi, and in this case set A and set B are known as disjoint set. Okay, in this case set A and B are called disjoint set. So when two sets are disjoint, their intersection is phi. Okay, when two sets are disjoint, it means there are no common elements. Okay, there are no elements which are common to set A and B. It means intersection is phi. Okay, so this the disjoint sets can be represented by a Venn diagram like this. Okay, Now, what if we have three sets? If we have three sets, then again we will take a rectangle which represents a universal set, and then we'll take three sets like this: set A, set B, and set C. A, B, and C. Okay, A, B, and C. Now suppose if we have to represent B union C, means we have to show that show B union C using Venn diagram. B union C using Venn diagram. So B union C means all the elements of set B and all the elements of C, including their common elements also. Okay, so where is set B? So without thinking anything, you just shed set B and set C and their common elements. Okay, so let us show this B union C, means set B complete set and set C complete set, including the common part. So where is set B? So you shed set B. This is set B. Okay, this is our set B. Now we have to find union with set C. So where is set C now? So this is set C. So this shaded portion shows this B union C. Okay. Now second, how to represent A intersection B? If we have three sets, then how to represent this A intersection B? So first we'll take a rectangle which is a universal set. Then we have set A, set B, and set C. If you observe, you will find that set the shape is means the shapes are different because it shows that they have different elements. Okay, suppose in set A we have 2 elements, set B we have 3 elements, in set C we have 5 elements. Okay, so here we have to show A intersection B, means the common portion between A and B. So you just forget about this C and only concentrate on A and B. Okay, only concentrate on A and B. Now you must be thinking, if you have to find A intersection B, then why there is a need to draw this C? So why there is a need? Suppose in question, if there are 3 sets, then we need to draw all the 3 sets in the Venn diagram. Okay, so here we have 3 sets, set A, B, and C, and we have to show A intersection B. So where is A intersection B? So to find A intersection B, what we will do, we will completely forget about this set C. Now see where is A and where is B. So here is A and here is B, and this part shows the common. Okay, it's a common part between A and B. So this represents A intersection B. Okay, this shaded portion represents A intersection B. Now third is, in third part we have to show that A intersection B union C. This we have to represent. A intersection B union C. To how to represent? We'll draw a rectangle first. Then as usual 3 sets, A, B, and C. So first we'll see the bracket B union C. B union C means the whole B and whole set C. Okay, whole set B and whole set. Now we have to take common portion between B union C and A. So what is common between A and this B union C? Can you see the common portion between this set A? So when you draw this set A, you will get your answer. So this set A and this B union C. So when you observe, you will find that this portion is common, this one. Okay, this shows A intersection B union C. So first we'll see this B union C. Okay. Now the next one is how to show this A intersection C. Okay, how to show A intersection C. So we have three sets, A, B and C. We have to show A intersection C. So let's completely forget about set B. Where is set A? This is set A and this is set C, and the common portion is this one. Okay. And the last one, how to represent A intersection B and union A intersection C. Means first we'll find A intersection B and also we'll find A intersection C and their union. Okay. So let us see where is, this is A, this is B and this is set C. Now first we'll find where is A intersection B. A intersection B means this portion. Okay, and A intersection C means this is A and this is C. A intersection means this portion. Okay. And combined means union. Union means common. Not common. Union means this A intersection B and A intersection C both. So when you write both together, you will get this one. Okay, this whole. So this will be the answer. Okay, so this is the way by which we can represent any relation using Venn diagram. Okay. Now the last definition is difference of sets. Difference of sets. In numbers, we know how to find difference of two numbers. Okay, so the difference of set A and B the difference of set A and B in the same order belong to set A, means all the elements which belong to set A but not in B. So let us write A minus B. Okay, means difference of this set. So A minus B means we'll read A minus B only. Okay, we'll read A minus B. So it means from set A we'll delete all the elements of set B. That's it. Okay, from set A we'll delete all the elements of set B. So this we'll understand by taking an example. Here we have set A whose elements are 1, 2, 3, 4, 5 and 6, and set B whose elements are 2, 4, 6 and 8. Now we have to find A minus B. So what we will do, we'll concentrate here on A, because from A we have to delete all the elements of set B. So from set A we will delete all the elements of set B, and whatever the remaining elements, this will be the answer. Okay, so here we have 2 in set B, so we'll delete this 2, we'll delete this 4 and as well as 6. So other than 2, 4 and 6 we have 1, 3, 5. So 1, 3, 5 is nothing but A minus B. Okay, because these elements 1, 3 and 5 belong to set A but not to set B. Now similarly, how to find B minus A? B minus A means from set B we'll delete all these elements which are in set A also. Okay, so we have 2 here in B, but we also have 2 in A, so we will omit this 2. 4 we have in B but also in A, so we'll omit this 4 also. Similarly, we have 6 in B as well as in A, so we'll delete all the 3 elements. The only element 8 will be the answer, because this element B belong to B but not to A. So when we find A minus B, we have to write all the elements of set which belong to set A but not in B. And to find B minus A, we write all the elements of set B, means which belong to B but not in A. Okay, and from this result it is clear that A minus B is not equal to B minus A. Like in number system, 1 minus 2 is not equals to 2 minus 1. Similarly here, A minus B is not equals to B minus A. Now how to represent this difference of two sets using Venn diagram? So let us represent this A minus B first. So this rectangle represents this universal set. We have set A and set B. So A minus B means from A will delete all the elements which are in B. Okay, so this portion shows this is common portion, means here the elements here whatever the elements are here, they are part of A as well as part of B. So these elements are also part of B, so we'll delete this one. So from set A we'll delete this part, so the remaining part will be A minus B only. So this part is A minus B. So this is our A minus B. Similarly, how to find B minus A? Okay, how to find B minus A? This is A, this is B. Okay, this one is A intersection B. So from B, okay, from B we'll eliminate all the elements which are also in set A, means this common portion we will eliminate. This is A intersection B. So other than this, means this part shows B minus A. Okay, so this is B minus A. Okay, so this part is A minus B, and this part is B minus A, and this is A intersection B. So when you observe, you will find that this A minus B, A intersection B, and B minus A all are disjoint, mutually disjoint, means there is no common. Okay, there is no common element between A minus B and A intersection B, B minus A and A intersection B, A minus B and B minus A. So they all are mutually disjoint. So A minus B, A intersection B, and B minus A are mutually disjoint, means their intersection is phi. So if you take intersection between A minus B and A intersection B, it is phi only. Okay, A intersection B and B minus A, phi. Okay, so this is very important result.